Hey, this is Tim Fox. I'm going to be the presenter here today. Hi, so I'm Timothy Fox, and I'm talking to you today about the 5 big challenges with big data and how businesses can overcome them. So, okay. All right, so we're going to talk about the big data and the mandate for digital transformation, and we'll look at 5 big data challenges to achieve measurable value. We'll also be doing a demo in which we'll be demonstrating kind of how we could go about analyzing big data. Okay, so you see this quote here, digital transformation is the reimagining of a business, more in digital terms, using digital first as the way business gets done. So, so what are we talking about here? Well, this study here finds that 70% of the corporate value in tech is driven by network effects. So what do we mean by that? What's a network effect? Well, the network effect shows that the value in the network between various ecosystems and technologies. So you can see here in this slide that our assets of our organizations, we have to open them up and make them enabled digitally so they can be better consumed and participated. And we need a lowest barrier as possible. So now the examples here, you can see here we talk about through like web services, service-oriented architectures, SDKs, open APIs, social supply chain, online communities, etc. So we need to open up our platforms in order to leverage this network effect. And this has to be done in a way that's going to maximize the value of those assets in today's network marketplace. Okay, so big data is on the rise. So now data itself, of course, is nothing new since we have since eons ago. We humans have been collecting data and trying to get value out of data. And this is only going to grow. So when we talk about digital transformation, we're talking about a data-centric viewpoint. And so data is going to be essential to that. Digital transformation is going to create more data itself as we move more and more and more of our assets digitally. Then the access and use of those assets is itself going to generate more data. So now we've seen here a great rise in corporate investment in digital transformation. You see here that in 2018, $1 trillion invested in digital transformation. But one of the drawbacks we have is poor data quality. So that's costing businesses millions of dollars every year. So as we, the saying says, garbage in, garbage out, right? So if we don't have quality data, then we're not going to get quality insights from that data. So everybody has data. We all have data, but only the leaders of that are really unlocking the data's value. Just simply having data doesn't necessarily give us any benefit. The innovative companies are the ones that are going to use the data to drive advantages in their business. Okay, so data speaks volumes. So there's a lot of things that we can track in order to give us a lot of insights and data. Now, imagine, for example, one thing that we use every day, internet search, right? So we go in, we type in some search terms. So that's good, we all do that. Now, what kinds of data is that going to be? Well, obviously, the search terms themselves are being used by the search engine to generate results. But did you know that there's going to be a lot of analysis done on the patterns of the search terms themselves? So, for example, Google, or whichever application we're talking about here, in this case Google, they're going to be analyzing patterns in how users are using search terms, how users are phrasing their queries, looking at things like spelling and punctuation, location, dwell times, click patterns. So these are all going to speak volumes about what's going on. And when we ingest this across millions or even billions of users around the world, we are able to generate a large number of insights. So today's world, we have the Internet of Things, right? So once upon a time, the Internet was primarily designed for computers, but that's no longer the case, at least not in terms of volume. Now everything from your sneakers to user sensor data to car races, etc., are making use of the Internet of Things in order to leverage the value of data. So, okay, are we there yet? Well, once upon a time, we talked about companies in Silicon Valley, like the Facebooks or the Googles or et cetera, as data-driven companies, right? So, but the reality is that every company is a data company. Every company's primary asset is their data company. And either you are going to be in one of three camps. Either you're already a data company, you were going to become a data company, or you're going to cease to exist. So, okay, so where digital transformation is already established. So as you can see, in some domains, we have a broader range of digital transformation than others. So for example, you notice here that in some domains like telecommunications and advertising, there is digital transformation is critical in many cases. However, other parts of other sectors, less so, right? So now, this isn't to say that it not could be or should be, but you can see the kind of progress of this digital transformation in different areas. Now, customers' needs and viewpoints are changing, right? So we all have our mobile devices that we use, and those are going to be the experiences that we're accustomed to. So when your customers engage your product, your company's product or services, they're going to come with those same expectations. They want something to be personalized, right? So the typical smartphone apps that we use every day, we take personalization for granted in these things, right? And there is not a one-size-fits-all kind of approach that's going to match. Customers expect that their experience when using your product is going to be tailored for them, and they don't want to be forced to have to fill out questionnaires and other things like that in order for you to try to get to understand them. They want you to, they expect that you're going to, by the basis of your knowledge and understanding of them, to know what experience they want. Just as much as they expect Netflix to be able to recommend movies based on their prior interaction with Netflix, or Apple Music to recommend the music that they like. It's beyond recommendations, though. They want to see the content, and they want to be able to take the content with them that matches them, right? And so now that's obvious in places like Apple Music or Netflix, but this is now transforming not just that, but every company's product. Everything is designed to be personalized around the user. But how do we know about the user? Well, it's through data, right? So we are collecting data from connected sneakers, wearables, apps, etc. So companies like, for example, Nike, for example, is now a data-driven company. So you'd think that Nike was just about making shoes, but you'd be wrong, because Nike is, yes, they make shoes, but they are trying to enable athletes, runners, etc. And they're doing that through data. So now, The bad news is that 55% of big data projects are never completed. So, that is a part of the reality that we have. Now, okay, now here's some of the challenges behind this. First of all, volume. So we have a huge amount of data out there. Now, when we talk about big data, we think of things in these terms, right? The exponential increase of data. If you look at this, 2.5 quintillion bytes are being generated of data every day. 5 billion inquiries, 90% of all data that's ever existed on the planet has been generated in the last 2 years. Of knowledge workers' workdays, 60% are trying to spend to find and manage data. 43% of companies are dissatisfied with that. So examples of this is that, Facebook is generating about 10 terabytes of data every day. Twitter about 7 terabytes, right? So you might not think that your company has a big data use case, but if you think that, you're probably wrong, because there is a lot of data being generated. Now, you may not be capturing that data, and you should be. You may not be making use of that data, though you certainly could. But and one of the challenges is that a lot of this, the volume of data, it's difficult for a knowledge worker to know what to do with it. They don't have the tools to be able to analyze it. And so often that data just goes unexamined, right? So, okay. Now, certainly the volume of data is a big issue, but also another issue is the variety of data. So the kind of data that we see today has changed, right? So in the past, data tended to be, things in kind of traditional relational databases, et cetera, et cetera, et cetera. But now think about what kinds of data is being generated here. Things like news, audio, video, social data, images, emails, text, and other kinds of unstructured data are, in terms of volume, the vast majority of data. And it's just not even like a close race. Traditional structured data is a teeny, 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 tiny little minority of data, albeit an important one, of course. But nevertheless, in terms of volume, it is a traditionally kind of structured data is a minority now in kind of vast ocean of unstructured data. The problem is, though, unstructured data is difficult to deal with. It's not nicely cleaned up and curated for you. It's more like, well, mining or refining that data rather than just using it. But if we can make value of that data, then we can have an incredible amount of value that comes from that. And of course, the Facebooks, the Googles, the et cetera, et cetera, et cetera. These companies primarily are trying to use unstructured data. So think about what kind of data Facebook uses. It's primarily unstructured data. The images you take, for example, the posts that you make, other things like that. All right, another challenge, V. Now, these all start with V. So we talked about volume. That's kind of the obvious problem. You use a lot of data. We talked about variety and the challenges in unstructured and semi-structured data. Now, what about veracity? Okay, now we could try to mine some data from the internet, but we all know that there's a lot of things on the internet that may or may not be actually true or correct, right? Obviously, there's actors out there that are attempting to peddle false information for their own purposes. Also, just beyond that, there's just a lot of misinformation out there, people's opinions that may or may not really be factual, and other people may be biased, etc. Right? So when flawed humans are being generating a lot of the data that we have, and we have to take that into account. That's one of the challenges that we have when we ingest the data is how do we allow our analysis to use, well, grains of salt when it does with dealing with the data. Now, what about number 4, velocity, right? So data comes in some kind of time span, right? So if, for example, I'm looking at stock prices, well, stock prices are going to come in at a certain time, right? If somebody buys 5,000 shares of Apple stock, say, then that order is some public information that we can look at and maybe take some action on it. But it happens in real time, right? If somebody clicks on something in your site, that's a real-time event. News, if there's some kind of news item that comes, that's a real-time event, right? So that's called the velocity. The velocity means is that our data is coming in real time, and in many ways, it's a race to that. Now, on Wall Street, they've been dealing with this for years, right? Real-time trading. And in Wall Street, they try to take, some kind of event that's happening in the world and then use that to trade on that and as fast as possible. So, but it's not really just Wall Street, right? I think overall in our business, we're needing to be able to react to data in real time. Real time, what does that mean? Usually milliseconds, right? So data comes, we need to do something with that. That's the challenge, velocity. And finally, vulnerability, right? So a lot of the companies have been very successful with leveraging and monetizing data, like the Facebooks or the Googles, et cetera. Their customers probably justifiably have privacy concerns. Now, that doesn't mean we don't want to use Facebook or Google. We all do. But we do have concerns about how our data is being used. And we expect that there should be some protections against our privacy, as well as protections in security to make sure that our valuable data doesn't fall into the wrong hands. Okay, so privacy is not about control over data. It is not a property of data. It's an understanding the audience and how far information can flow, right? So, so that's what privacy is about. Customers expect some degree of privacy, and they, in having bounds of trust, will then help them to be able to reveal data, allowing you to leverage it. Because if there are limits on how you can use the data, there'll be a higher level of trust, which means that customers will be more comfortable with sharing their data. Okay, now talking about from big data to smart data. All right, so yes, we know now, we talked about the 5 V's, right? So we know about the properties of big data. But again, simply having data it's not in itself going to bring us value, right? So we need to have smart data to allow us to make value out of the data. So let's talk about what a strategy is for smart data. First, I got to identify. Every company has big data. A lot of companies who don't know that they have big data have big data. But you have to know what your assets of data are. You have to take an inventory of that. And you have to understand what is the data that you have, what's its meaning, what's the potential value there. Okay, so the next thing is store. So obviously, we have to store the data. A lot of times, data is being generated, but it may not be stored, or if it is stored, it might not be easy to access. So we have to determine how we're going to store this volume of data. And number 3, provision. So we need to provide some rules and access guidelines for our data. So think about, there's a term that we use called data governance, right? So we have to determine how this data is going to be used, how it can be reused, shared, etc. Next, process. So we have to determine how the data is going to be processed. So we have to gather it, process it, right? So this is where we're going to make value out of our data. And finally, governance. So I talked about governance before when we talked about the rules and access to provision of data. But again, here's where we will need to make sure that the data is used according to the customer's expectation and response and regulators' expectation in things of privacy, security, that kind of thing. Okay, so what makes data smart? Well, one level of smartness is aggregation. So for example, let's say I go out and buy a share of Apple, right? So my particular trade, probably in the overall scheme of things, isn't all that important. I bought a share of Apple. Lots of people are doing that. But when I aggregate the data and we look at the trends around Apple stock, then that could be very valuable, right? So by doing aggregation, it helps us see the macro trends of that. And so, so whenever we layer our data, it builds better insights and goes beyond just the internal data set. Okay. Now, data normalization, right? So our raw data is rarely ever in a format that makes us useful. So data normalization allows us to create clean, useful data, allowing us to use familiar access patterns like SQL and that kind of thing to access their data. And last thing is data enrichment. So by taking our data, we can build metadata around our data. By enriching it, for example, with tags, say. Tags are a kind of metadata that then describes the data. That makes it easier to search, easier to catalog, easier to use. So, okay. Data is the new science, and big data holds all the answers, right? So that is our takeaway here as we are as we're moving ahead here in big data. So okay. Now, any questions so far? Okay, I'm going to do a little demo here. And this demo is going to illustrate some ways that we can access big data. Now, give me a second to get this up here. Okay. Okay, so we're going to be looking at a tool, not to necessarily recommend this particular tool, but we're going to be using a tool that can be used for big data. And give me a second here. It's called BigQuery. Okay. So now BigQuery is a tool on Google Cloud Platform, and it is a kind of like a massive scale data warehouse. So now, unlike your typical data warehouse, this is going to be something that can run on literally thousands of different machines. And it's done in such a way that you don't even have to necessarily be aware of what's going on behind the scenes, but nonetheless, that is what we have. So, okay. So many of you are probably familiar with a family of technologies called Hadoop. And so Hadoop is sort of the foundation of most of what we do kind of on the technical side with big data. But Hadoop is hardly a new technology. And BigQuery kind of represents a kind of an evolution of the core technologies around that. So, okay. All right. So we're going to be using this e-commerce data set here. And so what we're going to do is that we're going to go ahead and look at this data set here real quick. Okay. All right, so we're going to look at this e-commerce data set, and we're going to look at this one. All right. So this, you can see we have a schema here that shows the the schema. We can look at this. We can also do a query of this one. Okay, so you can go ahead and see here. This is what we have. So this represents the sessions that we have in a given e-commerce data set here. Okay, now in this case, we did a preview of some of the, let's see how big this data set is. All right, so we have about 21 million rows in the data set. So that really is not a data set that's big by big data standards, but it is not a small data set either. So we'll go ahead and take a look at that. All right, so now one of the things we might want to look at in this case is let's try to do some queries here. Now, one thing we might want to see if there is any duplicate data here and if we can kind of dedupe that data. So let's go ahead and do this. Now, BigQuery here is using a SQL kind of interface. So that way it's going to be familiar to those of us who already have a background with some kind of SQL database. And notice one way I'm doing this here is, what I'm saying is I'm saying, select count as num duplicate rows here, and I'm grouping by this. So I'm going to see here what rows have more than one dupe. Okay, let's see here. Okay, so you can see here it's running. Now, to do this, it's going to have to sequentially go through all of the rows in the database in order to try to determine if there is. So let's go ahead and take a look at this really quick. Okay, and you can see here that, okay, so it actually went and processed that. Okay, so you can see here that about 600, so we have here the rows, it says 615. So it looks like about 615 rows are duplicated in our data set. So this is something that we, when we're analyzing data, we're probably going to want to find. Whenever we deal with big data, a lot of times our data isn't perfectly clean. And so having some duplicate data there is there. Now, in this table here, this all sessions table, we've actually gone ahead and deduped that. So let's go ahead and I'm going to go ahead and run another query here. All right, so here what I'm going to do is, and I'm going to do this from the all sessions table. Okay, let me go ahead and run this. So what I'm going to be doing this, and I'm going to be seeing if there's any of the same query, basically. I'm going to see if there's any duplicates here in this all sessions table. Now, one thing that's important to know is that BigQuery will automatically provision as many machines in the cluster as required for the query. And that's done dynamically at runtime, right? So if we, obviously, while I'm sitting here waiting, I don't need any query time. I don't need any query processing power at all. I'm just not doing anything with my data. But once my query is actually in operation, then I do. So what Google will do is automatically provision machines in the cluster in order to perform the query once we need it. Now, notice in this case, I didn't get any results. So that's good. That actually means that I don't have any duplicates there. Okay. Now, we have whatever was 21, we had 21 million or so rows here, right? Okay. So, but I might want to know how many unique visitors I had for my site. Seems a pretty logical thing to do. So let's go ahead and check that out. Okay. All right, so I'm just going to do a count distinct on that. Pretty straightforward. Let's go ahead and see that then. All right, so it looks like we have almost 4 million or so unique visitors, 3.9 million, out of the 21 million views. Okay, so that's interesting information, right? So of the 21 million views, we have about 3.9 million of those, or so, are unique visitors, right? So, okay. Now, let's also break that down. So what if we did this, but let's say we wanted to break that down by channel grouping. Okay, so let's check that out. So I'm also going to remove this product views, and I will do a channel grouping. Okay, and let me go ahead and just select this here. All right, so now I'm going to be grouping by channel grouping. Let's go ahead and check that out. Okay, so I can see how this visitors broke down here. So you can see here that I have that here. It looks like most of them are from this organic search here. Maybe actually instead of ordering by channel grouping, let's order by unique visitors. That might be more useful. Okay, so organic search and here is by far the most common. Okay. All right. Let's go ahead and see what products we have here. So, all right, I'm going to go ahead and look at my all sessions again. Let's go ahead and run and get the unique level, the unique product names. All right, here we go. So it looks like we have 633 unique products. We have hand sanitizer as our number one, etc. Okay. All right, so whenever we're capturing this, there's some different kinds of views that we can have. There is, and so let's go ahead and actually break that down. Okay, so what we're going to do here is we're going to do account product views for product name, and we're also going to say where type equals page. So there's different kinds of events that we can have that versus a view, but page is probably what we're looking at here. Page here is where a user actually visits the page. Okay. So what we're doing here is we're getting the first 5 page, for the top 5 product views by page. So it looks like the top one is Google men's 100% cotton short sleeve t-shirt, hero t-shirt white. Okay. Okay. Now we're getting this product view, but they're actually, people are viewing the product more than once, right? So we should really just count each one per visitor. So what we can do is we can go ahead and first, let's go ahead and create a temporary view here, which is called unique product views by person. And then what we're going to do is we'll aggregate that. So okay. All right, so now we're no longer double counting this. So you can see here, here's our unique view count. Now, let's also look at the product quantity as well. So in terms of orders, right? So in this case, now we're going to relate the views to the orders. So let's go ahead and do that. Okay. Notice, by the way, that I changed this query, and it pretty much ran instantly with the change query. You notice that? When I had run it before, it took 2 or 3 seconds. Now, when I ran it here, even though I had went ahead and grabbed some additional things, it came back pretty much instantaneously. So that's because now that I pulled the data into cache and that sort of thing, then you will see that query much faster. Even though it was not slow to begin with, of course. Okay, so here you can see the product view also got the most orders. So that isn't too surprising, but it would be interesting to look at because there might be some kinds of products that get lots and lots of views, but maybe relatively fewer orders, right? So so that sort of depends. One might guess maybe a very expensive product might get lots of views for people kind of, ogling it, but not necessarily buying, right? So, okay. So because of that, let's look at the average amount of product per order. So okay, so here we have the average per order. Okay, and if we look at this, the highest average per order is apparently here is this one. But actually, why don't we try to see that, because we're saying limit 5, rather than doing a order by product views, let's order by average per order. Okay. And in fact, now we see the highest average per order here is actually the black vintage badge T. So there you go. Okay. All right, so this is our demo. So basically what I wanted to show here was I wanted to show a tool, in this case, a cloud-based tool, where you can do kind of big data analytics in action. Now, this isn't necessarily to say that you have to use Google or BigQuery. This is an example, and BigQuery is built on top of a lot of the same basic technology that you often we see kind of in the big data ecosystem more broadly. So for example, in the Hadoop ecosystem, we have a number of similar kind of similar SQL type engines for accessing big data. Like, for example, Hive is probably the best known, but maybe one of the older ones, and there's some newer ones as well. BigQuery is a Google product, but it also does something similar. It gives us a SQL kind of interface to doing these kind of analytical type of queries on our big data in a way that auto scales up to whatever level we need to scale to. Okay, so that's the demo. And that actually that basically brings us to the end of my presentation.